All right, folks, let's go ahead and get started. 1 o'clock. So this is going to be the ArcGIS API for JavaScript, Programming Patterns API Fundamentals. My name is Renee Rubalcava, work on the JavaScript API here with Matt Driscoll, who does some awesome work on widget stuff and everything. So he's open to questions. Thank you all for being here. Last session of the week. Hope you guys get some pretty good stuff out of this. So basically, this session is pretty much just kind of above the what's new a bit. This is kind of the core stuff that you probably should get a handle on if you're going to be working with the JavaScript API. There's a lot in here, like I said, but this is just more to give you an idea of the different patterns you're going to come across when you work with the API. Hopefully answer some of the questions you might have before you start diving into some parts of the API and start working with some things. How many people have worked with the 3x version of the JavaScript API? Okay, cool, all of you. Anybody here start with 4 stuff yet? Starting, kind of? Okay, cool, cool, very good. So this is the kind of a rough agenda. I think it's still valid in the way that we've laid it all out. Let's go over just some of the fundamentals. So this essentially is some really cool stuff if you are more familiar with 3 than 4. But one of the big things we did with 4 is separating the maps and the views. So right now, when you create, you would, in 3x, you create a map, everything just kind of happens. It shows on the page and all that. But with 4, what we're doing is the map is just kind of the data, a model for how things are going to look. It contains layers and your extent and information like that. And then you need to attach that map to a view. This could be a map view, as we see here, or it could be a scene view. And you'll notice here the 2 APIs are essentially identical in this particular scenario. And we'll see later on some of the differences between the map view and the scene view. But the APIs are consistent across the board when you're going to contain them both. So my mic, no, there we go. So the map, like I said before, it's kind of the data model for the your maps and the layers and everything. It contains all the layers. We like to say it's what the world's composed of, and then the views are a window on that world. So it's the views that are in charge of drawing everything. And we have 2 different drawing pipelines, just to get a little technical, between 2D and 3D. Just kind of makes sense the way that we do things. And if you think about it in this little chart diagram we have here, the views are going to pull information from the model, which is going to be the map, and get all the data that needs to be able to draw things. And it's interesting to note here that for every layer that's part of the map also gets its own layer view. So the view really is a manager of layer views when you start looking at this context. So each layer gets a layer view. What this is pretty powerful, because what you can do at this point is you could have one map, have multiple views, and then via the layer views, you can control what layers are on and off in each of those views without having to interact with the map anymore. So it kind of lets you do some pretty cool things. We have a couple of samples in the SDK that kind of show that idea of using one map and multiple views. This just kind of highlights the fact that the map for 2D apps, we get a map view and a map and the web map. And then 3D apps, you would get the scene layers and the web scenes. Let's talk about parts of the map, though. So a map can be broken out into 3 different pieces. We have the base map, which I'm pretty sure everyone's familiar with. We have operational layers, which apply everywhere. This is everything that's not a base map. But for 3D, we also have ground. So ground is a specific type of a layer that's in the map. And this is for elevation data and stuff. So just create a map. It's pretty simple. We provide a bunch of strings you can use to create these maps that are shortcuts to different base maps that we have as part of the platform. We have a bunch of vector tile based maps. We have a string for the ground, which is world elevation. And this is just a shortcut to Esri's world imagery, world elevation layer. That we provide out of the box. And you can update these. You can customize these as you wish. So you can go ahead and create a base map object. And there's a property called base layers. This would be something like your aerial imagery. You could create your own custom base layer with your own aerials. And then a reference layer, which would be something like maybe county boundaries or maybe the text for cities or regions that you want to show. That could be a different layer, so that's the reference layer. It's always drawn on top of the base layer, and this is a really cool way to create your own custom base maps. And if you have your own elevation layer, you can go ahead and provide your own elevation layer under the ground property. So that's kind of an interesting thing you could do. Anytime you see us show any demos or something like that, we're like comparing the old elevation to a new one, like in a landslide demo or something. That's essentially what we're doing. We're just switching out the ground layer with a new elevation layer to update that image. So we got a little sample here on creating a custom base map. So in this case here, I'm bringing in the elevation, the hillshade service as my base layer. So it's not really my aerial imagery. I'm bringing the hillshade in here. And then I'm bringing in the vector tile layer for the topo reference data, which is all the streets and labels and everything like that, which gives me a really nice looking little map over here. And if I rotate it, so we can notice it with this Fairchild's air garden right here. If I start rotating my map on this Mac, that'll work. Yeah, you see that it all stays horizontal, which is really kind of cool. It's kind of what you want when you're working with maps. This is kind of a recommended way you guys create your own base maps when you push to production. It's just a cleaner way to do it. You're welcome to use the shortcuts that we provide and everything like that, but if you really want to get some more fine-grained control over your apps when you're pushing them out there, this is a really good, handy practice to start using. It's pretty powerful too, so it gives you a lot of control over things. So layers, let's talk about operational layers. And like we kind of said, operational layers are anything not base map, not ground. So this is going to be any map image layers, KML, feature services, graphics layer, anything like that is going to be constituted as an operational layer. And that's all in an object on the map called layers. And you could either define these when you initialize the map, or you could define them after you create the map. It's up to you how you want to start adding these different layers to the map. So this is just kind of goes over some of the stuff we talked about. So the thing you can do here is, like I said, the best for base maps, it's nice to be able to control what goes in your base maps, and you have a little bit more fine-tuned ability to add these reference layers and stuff, which is kind of neat. And if you, unlike 3x, if you want, the layers property only has operational data. Base maps are not included in there, neither are the ground data. But if you need, for some reason, to iterate over all the layers that make up the map, we do provide an all layers collection that you can then go ahead, iterate over to find your information. Maybe you don't want to, maybe you want to display these in some sort of information panel you have on the side. By default, most of our widgets aren't going to really reference the base maps and stuff like that. So when you add them to something like the layer list, or the legend, I mean, they won't be in there by default, but you can always kind of force them in there if you wanted to. Let's talk about a few of the layers. So tile layer is probably one of the ones you're most familiar with. This is just a raster tiles where you pre-cook the tiles ahead of time, publish them, and you can access them. This is probably one of the most popular layers that we have in the platform. You can create that by just give us an object with the URL, provide the ID. There's some other options here. We have the visibility. There's also opacity. You can provide min-max scale that you can provide. You can overwrite the min-max scale of the published service if you wanted to. And we have web tile layer. And I did want to show web tile layer just because it's a pretty powerful layer in the API that you can take advantage of for referencing layer or services that are not Esri published services. So if you want to reference a service somewhere that maybe didn't come from an ArcGIS server, this would be probably where you want to take advantage of that. The way this kind of works is that you provide the URL. Typically with any tile services, you have these subdomains. This lets us make multiple requests for tiles. You just provide those subdomains as well. And then if you notice over here, we have this level column row. That's kind of how tiles are stored. They can vary every now and then depending on the kind of tile service that you're using. Just give us that tile where the level column row is going to be. That way we can request the tiles correctly. And we always recommend that you put your copyright in there. Good practice to add copyright from whatever the source of the data is coming from. Let's look at a quick little sample for this. This is directly out of the API we're going to load some Stamen base map tiles into a 3D scene. So we just load them in here, and they just act and behave like they were any other tile service once we've already predefined what they're supposed to look like, which is really kind of cool. So this lets you work with some other tile services you might have out there you want to use. Graphics layer. So graphics layer is pretty popular. Graphics layer is kind of a bag of graphics. You can throw anything you want in there. Points, lines, polygons, doesn't really matter. It'll take whatever you put in there. But it's good to note that any graphic you add to a graphics layer, you're in charge of adding the symbology for that. There's no renderers used with graphics layers. So don't use these for things that are important, really. This is more like if you're doing some kind of a redlining, sketching, or maybe some highlights that you want to add your own in here. That's more what the graphics layer is for. It's not really meant to be for data that's probably better suited for a feature layer or creating feature collections. So this is how you add graphics to a graphics layer. It's got a graphics property that's a collection, and you just dump your graphics in there, and you can add graphics after the fact as well, and remove them and so on. And like we showed over here, you can still add pop-ups and attributes to graphics. I mean, that's totally supported. It's just not recommended to use and try and treat it like a feature layer. You won't get the same functionality out of it. This is how you create a graphic. So I'm going to create a new graphic, and we'll see more about how this autocasting works later in the session. But basically, I'm just adding a graphic, all my properties to it, and then just dump it right into my graphics layer. And everything works pretty happily. But you see here that I do have to define my symbology when I'm adding this graphic, because that's one of the requirements you have to do. All right, feature layer. This is the big one. So this is the one you'll probably end up using the most for any sort of operational data, especially now with some of the new improvements that we're doing to feature layer. It's going to be able to do quite a bit more in the upcoming releases. So you basically have this that comes from a feature service, or you can create a feature collection. If create a feature collection, the property is a source on a feature collection. You just add graphics to a source, and then you can go ahead and add a renderer to this feature layer. But it's important to note here that unlike a graphics layer, they all have to be the same geometry. So you can't just start throwing points, lines, polygons to the same feature layer. It have to be the same geometry. It's not going to work. And you can't, I've seen people try and do this every now and then and ask me why, but you can't put a graphic with a symbol into a feature layer and have it honor that symbology. It's going to use the renderer to go ahead and display the graphic as the feature layer wants to display it. So you create a feature layer a couple different ways. So we have the ability to just do it by the URL or portal item. Portal item is really neat because it's just going to go ahead and work out of the box. You don't have to know the whole URL. And by doing this, you can go ahead and change the feature layer URL of the item at some point down the road if you want to update that. And you don't have to update your application. That's kind of an advantage of working with web maps and item IDs, is that you can do the updates to the item and they just get carried over to all of your apps. So stuff coming to the feature layer, or we have now the feature layer really, is WebGL. So we are planning to move the whole 4X API into WebGL, all drawing WebGL eventually. And right now we have feature layers in WebGL, and we can display a lot of features, a couple 100,000 or so features in WebGL right now. And we're going to try and push that some more. One of the reasons for this is that, yes, it's faster, but we've also kind of pushed the limits of what we can do with SVG, especially with lots of polygons and stuff. And SVG fill and different things you can do are just, they're really slow when you work with a large amount of data. So we are currently now moving things to WebGL. Currently, the only way hosted feature services, and that's just because of the way that we take advantage of some of the server-side things to kind of generalize the data right now with hosted feature services. But in an upcoming release of Enterprise, those features will be there as well, and you can start using the WebGL with that. And we're working on trying to make WebGL just work across the board, regardless of where the data is coming from as well, to take advantage of a few things. You saw some of that with the client-side querying and stuff in the plenary that we showed. We want to kind of have that work everywhere as well. So how do I turn on WebGL? Just this this little has flag here, and that's it. That's all you got to do. There's nothing for you to do in your code. We'll just handle the rest. If for some reason you give us a layer that doesn't, that's not a hosted feature service, we're just going to fall back to SVG. That's it. It's all done on the client. So we got a little sample here. Let's go and run this. So here I'm just creating a little feature layer, and this is actually a service I published a while ago that is, they are hex bins, centroids of all of the census blocks in the US. So I created these 5-kilometer hex bins, and I created the centroids, and then published them. It makes for a nice little visualization, and I can still interact with the map. And it's kind of hard to see here, but because they're points, there's a little highlighted guy right there. Might be kind of tough to see. Maybe over here it's a little better. But yeah, so you can see a little highlight there. So then we get highlights with WebGL in the API right now as well. So I think this feature layer is like 200,000 points, and that all drew pretty quickly, and I can still pan around and zoom in, and everything's really fast. So that's a really nice advantage of having WebGL. Map image layer. Map image layer is really cool. You're probably going to deal with map image layer quite a bit in your development stuff, because with map image layer, this is one of like the oldest kind of services that we have in the API next to tile layer. This tile layer you cook your tiles in tiles, essentially. We stitch them together. Map image layer, it's just like one shot. We ask for a bounding box, usually a little larger than the extent you're viewing, and we get an image back. But it also lets us go ahead and show more data than you could with like, with the SVG feature layer, the old way of drawing feature layers. We show more data. And the API for in 3x, which used to be called ArcGIS Dynamic Map Service Layer, which we wisely renamed to Map Image Layer. The API for those services on the REST APIs they're not pretty. If you want to update the renderer, because if you have the ability with those services to change what the renderer looks like. So if someone published cities with a blue background, you could change that to be transparent, or you can change it to be green with an opacity. You have that ability to do that via the REST API. But the client-side APIs for that were a little tricky. We simplified that down to these sublayers, which they just look like layers. And you can now control visibility for them. You can control the definition expressions. So you can filter the data that comes back with that image. And you can also apply renderers to them, which I think I'm doing in this sample here. So I have a couple renders I'm doing for my cities here. I'm going to make them yellow for the city points. By default, I think they're white. I'm doing a fill for my states, which is no outline and stuff. Oh no, none. And I put a little white or gray outline on them, which is tough to see here. And just apply that to my map image layer, like any renderer for like a feature layer or something like that, and get a nice result back. And they're pretty quick. So I go there and I get another image back. And I come here, get another image back, and I'm good to go. It's a great way of being able to work with your data sets. It's powerful, and it's good stuff. Important to note, if you'll notice here, ID 0, 1, 2 in reverse. This is the drawing order from bottom to top is the drawing order, just to note, because we got that question a couple times. Scene layer, I do want to show scene layer, because 3D is awesome. It's got some cool stuff in there. And scene layer works just by going ahead and providing a URL like anything else. All right, so I create a scene layer here. Although in this case here, I'm doing some visualizations and stuff. So if you saw any of the visualization sessions this week, they might have showed some pretty cool stuff with scenes and whatnot. What's cool to note with scene layer is that with the i3s spec and everything that we have, they're optimized to, scene services are optimized to publish lots of data, and the scene layer is optimized to consume that data very efficiently. So you can get millions of features into a scene layer and the scenes and consume them in the API pretty quickly, which is kind of neat. And I think there's a couple 100,000 buildings in here, maybe more. And one of the data sets we have is like 1 million buildings, which all come up pretty quickly. So you can see how that can be pretty powerful when you're publishing some 3D data, which is really cool. Layer views, I did mention layer views earlier. So when you create it's just a little diagram. When you create a view, it's managed the layer views essentially. The view just controls like what the extents and everything are, but it's the layer views that are doing all the real hard work of drawing stuff. This kind of misleading here, limited APIs so far, not so much anymore. I was thinking about this from earlier in the week. It's come a long way, especially in the next iteration of the API, where you'll be able to do client-side querying and statistics based on the data that's available to draw. I think that the API is really moving forward quite a bit more. So I wouldn't say it's limited so much anymore. But one of the really cool things with it is that you can do quite a few things when you have that layer view available to start doing things. So if you want to get the layer view, you have a couple of ways. We have this method called when layer view that's on the view. You pass the layer that you're interested in to that when layer view method, and it's just a promise that's going to return when the layer view is done and ready to go. Because the layer views do take a little time to spin up and get things going, at least more time than just kind of asking for it and it's automatically ready. It takes a few milliseconds or so. You can always get them after everything's drawn in the all layer views collection. It's kind of like all layers, all the layer views will be in there. Let's look at a little sample here, kind of how this works. So I've got this little note functions utility helper from our watch utils to be able to watch for changes on properties. So I'm interested in a property that's going to be nothing once. I only care if the value is false or undefined, whatever, one time. I don't care about any other times. So I have my layer here, and I'm going to ask my layer view for the when layer view, pass my layer. I get a promise back. It's going to give me my layer view. Now remember, the layer views are responsible for all the drawing of the data, so they're constantly updating. They're fetching data and getting ready to draw that data. So if it's fetching data, you can't really do much with it because the data hasn't gone through the pipeline of the layer view at that point. You need to know when the layer view is done updating. So that's why you have to wait for when the layer view updating property is false. When it's false, you can go ahead and you can do queries on the layer view. And then I'm just going to go ahead and zoom to it in my particular sample here. So if I rerun this, you'll see I'm at the full scale, and then I zoom in to that particular layer. This is the kind of stuff that you saw in the plenary, these query extents and stuff. These queries happen on the data that's on the client, essentially the data that's available to draw. So like in the sample I've shown the plenary where he's going over the hurricane map and he's finding the strongest hurricane, that's all done on the client side using the layer view to do the queries. And you can also do it for statistics and everything else coming up in the next release. That's going to be on the CSV layer, which is really cool. So that's some pretty cool stuff going on there. Like I said, if you go to the layer and you query features, we're going to go back to the server to get the results. We're not going to check the client-side data because we assume that maybe you want to query something that maybe we don't have available to draw at that point. If you do layer view query features, we're going to query the features that are currently on the client. And like I said, that really means stuff that's available to draw. Maybe it's not on the screen at the time. You might be panned around or something, but they are there and they're available for you to get to very quickly. So that's an important distinction to make. So at this point, I'm going to head over to Matt to talk about the widgets and UI.
Thanks, Renee. Okay, so let's talk a little bit about widgets and user interface in our API. So all the widgets have been redesigned from the 3x version, and they have a different, better user experience that's more focused on accessibility, providing a better user experience for users to be able to get to features and navigate, stuff like that. And it's more extensible, so you can recreate widgets more easily, customize them more easily, and do things like that. So kind of like we have the map and the view separated, we also have a widget view and a widget view model. So we keep the data and the presentation separated, and we'll talk a little bit about this in a second. So as far as styling our widgets, all our widgets use Sass, which is a CSS preprocessor. So you can write code in Sass and then compile it to CSS. And this gives you advantages of things like variables in CSS and functions, mix-ins, and overall lets you write less code. So looking at our styling guide on our API, you can see that if you want to include styles for your app, the main thing you need, or the very little thing you need, is the view.css. And this will lay out the map and the view for presentation. And there's also the main.css, which includes the view CSS plus styling for things like widgets and zoom buttons, stuff like that. Our view also has a bunch of different classes that you could take advantage of if you're developing user interface for the view. So you may have your view at full screen, 100% width and height, but and in that case, you'd be able to use media queries to kind of style your user interface depending on the size of the browser. But also you can use our view CSS classes. So if your view is embedded inside the page and it's a different size than the window, you can take advantage of these classes to be able to style your user interface depending on the size of the view. So they're pretty helpful for doing things like that, making your apps responsive. Also, our API has a bunch of different themes out of the box, such as light, dark, light blue, dark blue. And I'll have a little demo for this a little bit later. And then it kind of covers the widget CSS and then kind of the variables you can tweak for Sass to kind of create your own theme. So this guide is pretty helpful for that. And there's more information on Sass in this document too. So a little bit about the CSS themes. This is a demo showing a bunch of our widgets. So here's like the layer list widget. We got search box there. And basically this is using the default style sheet for our API. This is a light, but I can also change to dark, or if maybe my app is more dark red, maybe fit this better because of the base map. So it doesn't stand out quite as much and kind of blends in, and the map kind of is the highlighted part. So there's all these different style sheets out of the box. And with Sass, you can kind of tweak them and create your own theme for your brand or app. So all these Sass files are available on GitHub. If you go to the JavaScript API on GitHub, you can get all the references to how you can structure your own theme and customize widget files, stuff like that. So a little demo of all the out-of-the-box major widgets we have. See, the direction is going to prompt me real quick, so let me just enter my info. The directions widget requires a login for services to do credits for routing, so that's why it prompted. But so, for example, here's a bunch of widgets on this map view. We have the base map gallery, which will let us change base maps. We have the directions widget. We can route to locations. We have the layer list, so we can turn layers on and off. We have, our zoom controls, pretty standard. We have the rotate, compass. In 3D, we'd have these navigation tools to be able to change between panning and rotating. We have a full screen widget, a legend, locate me, print, and then track. And of course, we also have the pop-up, which is responsive. So as I shrink the map down, things get smaller. And then if you get down into a mobile state, it'll actually dock to the bottom and allow you to see it that way. Also, we have this expand widget, which can contain other widgets. And so at a mobile state, when that's open, it'll kind of get this panel. So you're not taking up the whole view when you're interacting with those widgets. So those are all pretty cool things. A little bit about the view model I mentioned a little earlier. It is the brains or the logic of the widgets. So this handles all the key functionality that the widgets are going to do and provides an API for the view to use to be able to create an interface for. So if we look at a sample view model, this is for the zoom widget, pretty simple view model. Has a few properties, whether or not it can zoom in or zoom out. Has a state to say whatever, if it's ready or disabled or whatever. And then the view that it's going to use to be able to zoom in and zoom out. And then it has a couple properties. We just mentioned those. And then a couple methods, zoom in and zoom out. So pretty straightforward stuff. Now, views are the presentation of the widget, so they're the actual interface, and they extend this class Esri Widgets widget. So if you want to create a widget in our API, this is the class. Oh, we lost the screen. Let's see what's going on there. No? Oh. That's not good. Okay. Well, I need my dongle then, though. Oh, what happened?
We're grabbing the dongle. 1 second.
Yeah. It's not back? No? Okay. We'll try HDMI. 1 sec. Sorry about that. Let's see if this works.
That was just 3, I think.
3. And nothing? Okay, let me open up my preferences, try to get this fixed. No screen?
Neither one's working, right?
No. Is yours working?
Let me try. It figures there'd be a technical difficulty.
Of course,
on Friday, right? I mean, my screen does its weird little thing telling me I'm somewhere, but...
yours isn't working either, huh?
No. Do we have an AV guy out
Any
here?
AV people?
No one's
not
here? I guess not. I don't think they're listening to us either.
I'm still on 4. Let's try that again. Nothing changed, so it's kind of weird that it just stopped.
I mean, this thing's on. I don't know.
Are they turning the power off on us already? Kicking us out?
Let me look around.
Yeah. Nothing changed here, right?
No, nothing changed. We're just...
It looks like they're checking it out. Oh, okay. So I guess they cut the power on us. Sorry about this, guys.
They really want you guys out.
Yeah, I guess so. Well, I guess we'll take a little break until they get this fixed.
Any questions right now?
Yeah, we can take questions while...
You said the WebGL, the large number of points, it only works now if you're publishing that online?
Yes, right now it's only for online. I don't know. You have to have server guys. I don't know if it's in 10.6 or not for those same capabilities. But one of the things we're trying to do with the API as well is to not have that limitation in place, which is kind of what we saw. Okay, we're coming back.
We're getting back.
But just to point out, that's what we saw for in the CSV layer in the plenary. That's not hosted. That's just all CSV. So we want to get to that point for everything. All right, cool. It's back to our regular
All right,
show.
we're back online. Okay. Sorry about that, guys. All right, we were talking about widget views. As I mentioned, Esri Widgets widget is the class you want to use if you're creating your own custom widget. So all our widgets inherit from this class. And this is right here in our documentation. So if you go, it's just a widget class, and there's a bunch of guide helping topics for creating a widget and samples and things like that. So the widget views, they rely on the view model for the logic, and then they render out in whatever way they want to. So their focus is just on user interface, and every view for every widget we have is available to download, so you can look at what we're currently doing for every widget. And if you want to, you can take that widget and tweak it and make it your own. So sample widget demo here. So what I've done in this, and I'll kind of show the code off first. Widgets. Okay, so basically what I'm doing here is I'm requiring the search view model. And in a really simple widget where I'm not using our framework, I'm just going to use an input box with a placeholder and a form element. And then when that form is submitted, I'm just going to call the view model search method with the input box's value. And then I'm going to add this basic input box and the form to the top right of the view. So this is a really simple demo on how you could use a view model for the logic part and present your own custom view if you wanted to. So the Widget Development Doc, I mentioned that. It's just on our API page, and there's tutorials, and these links will be available in the slides we share at the end. So the view also has a user interface property, and this we use to manage the placement of widgets, and you can put any other DOM nodes in there as well. The user interface also has padding, so if you want to offset the view in different locations and put something there, you can do that. So the view has padding and the user interface has padding, and this kind of allows your application to tweak and place things and have your user interface in a specific way. We also have a list of well-known widgets that you can set via the user interface components. So by default in the map view case, you're going to get automatically the attribution widget and the zoom controls. And in scene view, you're going to get attribution, a navigation toggle which switches between panning and rotating, compass, and the zoom controls. And you can turn these on and off as you see fit, and there's other custom ones you can just add by using a string as well. I want to point out the user interface guide here. This is a really good example for seeing how these kind of things work. For example, if you want to place your logo on the bottom right, you could easily do that just with CSS or by using the View UI. And there's a bunch of other information here about that. Quick little demo on the View UI. So right here is I have default user interface positioned just in the top left. I can go into UI, add padding. So let's say I want them offset by the top, left, and right. I could easily just do that, set my default components, and then I'll get some spacing here reserved for whatever I want there. Just to restate this, you can use the View user interface to position things. So if I have like a legend that I'm creating, I want to add that to the top left, I can easily do that. There's also a manual positioning option. So when you use that, it's going to add it into the DOM area that you want, but you're going to be responsible for positioning it yourself. So by default, I'm using a legend here. I'm using manual UI positioning. It's just going to go in the top left there. And what I'll have to do is go into manual positioning demo. And I'll have to, see right now I'm just creating the legend here at the bottom, adding it manual positioning. And so if I want to get this positioned where I want to, I'm going to have to add my own CSS to position that. And then it'll go wherever I want it to go. So in this case, I'll just have it at the bottom there. Pop-ups, like I mentioned before, pop-ups, fully responsive. You can easily set pop-ups on layers by using a Popup template. So for example, I have a feature layer here. I'm setting the Popup template to have a title and content, which will just display all the fields. You can also have content of a Popup template that is an array of different type of things, and that could be like field infos or like a table of fields. It could be strings, it could be HTML, it could be media, charts, and here's how you would set that. So the Popup template content, like I said, could be string, it could be an array of these different kind of types, which could be text, media, fields, or attachments. You could also set the content to use a function to return something. So if you want to do something slightly different for every feature, you could do that. It could also be a promise, so you want to do something asynchronous and then return what to display in the pop-up. That's an option as well. Fields also have like field infos. When you're using field infos in a pop-up, you can format things like dates and display, nice standard formats. Here's an example using HTML to set a content of a pop-up. So I have this, header, and then a divider, and then a list of different fields I want to display. I could do that. I mentioned media infos. Here's how that would look. So I want to have this media in the pop-up, And I'm going to use a column chart with a title, and I can give it a little bit of display information there, what fields to use and what theme. Pop-ups can also have these actions or these buttons at the bottom. And so you can use that to do custom things that your application needs to do. I have a simple demo where I'm just going to have a pop-up here, and then this action is going to use a property of the feature's attributes and just go to a URL. So let me show off the code for that. Widgets Popup Actions. So in my Popup template, I'm setting action, and I have this action with an ID that I need to set, and then I can give it a class name for whatever icon to use for that action, and then a title. And then so when someone clicks on this action, I have to listen for the Popup's trigger action event, and then I look for the action's ID that I set, and then I can get information about that feature that was clicked, and open a URL or do something custom. So it's kind of nice to be able to customize your app and do specific things with features that are selected. Popup also has the ability to dock to sides. So you can set things like whether it should dock at a specific breakpoint, whether it has a dock button, and where to dock the pop-up. And all this documentation is available on the API for the pop-up right there. So you can set like the height and the width for the breakpoint, where to dock, all these options for where to dock. So let's look at a demo for that. By default, the pop-up, if you have it docked, the dock position is going to be auto. And what that means is as I resize down, it's going to go on the top right, but then go down to the bottom in a more mobile size. But I can also just say, I always want it bottom center, and it'll just kind of stay there. So just whatever your app kind of needs, wherever you want to position things. You might have user interface on the side, and so you don't want it to dock there. Pop-ups can also use Arcade, and so you can have these expressions which take values of the features and do things with them. This example right here would be really simple, so it's just adding feature properties, feature attributes up. So there's a bunch of information here on how to do that. Our ArcGIS for Developers Arcade page will give you a bunch of examples and help for writing these expressions that you can take advantage of. So in this simple demo, I'm just following that same thing, and I'm adding up items. So we can look at that code, Popup Arcade. So I'm just setting a Popup template, and I have a content which is going to use my Arcade expression. So it's going to say the total number of items. And I can define this expression right here where it's adding up different attributes right here just to do a simple sum. But you can do pretty complicated things with Arcade. More advanced way of setting pop-up content. I mentioned earlier you can use a function, and then you can get the graphic from that event that's passed to the function, and then return something unique about the pop-up, the selected feature of the pop-up. So in an advanced demo here, I'm using a function to return a column chart based on the feature's attributes, a value in the feature's attribute. So if we look at that pop-up content function, so when the view is clicked, I'm going to create a feature. I'm going to give it a pop-up template, and the content, I'm going to use a function, getChart, which up here is going to use a chart.js chart, create it based on the graphic attributes, and return the canvas element there. So that's a way you can use like a function to set the pop-up content. I'm also using one for the title here, where I'm just getting the title in the attributes. You can also set pop-up content via promises. So each promise would return an array of graphics. So you can set pop-up.open use these promises. As these promises are resolved, you're going to get back features, and it's going to populate the pop-up. So in this example, I have asynchronous things going on. As I'm getting features, it's going to show a display spinner, and it's going to repopulate with the features. So let's show how that code looks. So here's my pop-up template again. Here's my promises that is going to resolve after 1.5 seconds, and it's going to return a couple of graphics. This one, after 3 seconds, it's going to return another graphic, and this promise, after 4 seconds, it's going to return a couple more graphics. So when I open the pop-up, it's going to get the content from these promises and open the pop-up. So let's talk about the ArcGIS platform now. All across the platform, we redesigned to be more developer-friendly, and things are more consistent. One of the big ones is the portal API, where you're fetching items and loading portals and stuff like that. So things like accessing base maps, content, querying items, querying groups, users, loading items, they all have a similar feel to them and all use kind of the same APIs. So in this example, loading a web scene, you're going to say new web scene and get it from this portal item of this ID. And then you can just pass that to the view. Here's an example loading from an item. So I'm going to get a promise back from layer from portal item. This is the ID of the portal item, and this is the portal that it's going to use. And then once it loads that, I can add it to the map or handle some error. Same thing with portal. I can say, new portal, set the auth mode. Once the portal is loaded, I can query some items from the portal and then create a gallery. So let's talk about programming patterns. One of them is interactivity with view events. The view has a ton of different events you can interact with, the most common one being click, but there's a bunch of them here you can use. Let's look at that real quick. So click, you can listen for double click. On the view, drag, hold, key down, key up. A couple new ones coming at 4.7 is focus and blur, so you can be able to listen to that. So there's all these events you can take advantage of in your app. And if you don't want something to happen when user clicks, you can stop propagation. So here's a demo I'm going to show right here where I've disabled the drag on this view. So as I drag, you're seeing I'm getting the event called drag, but I'm stopping propagation, so it's not going to let me do anything. So if we look at the code for that, all I'm doing is view.onDrag, log the event and stop propagation. Here's how you do something for Unclick. If you want to listen for Unclick, then you'd get a screen point, and you can do a hit test on the view to get back the top feature, and then do something with that graphic. View also has a method called goTo, and so you can pass this a target, which could be a graphic or a geometry, and it'll go to that location. So you can navigate to a geometry feature location. Let's see a little demo of that. So in this demo, after a second, I'm going to a location. Let's look at the code. So I set a timeout for 1 second, and I'm going to go to this point. But what I could also do is say, don't just go to the point, go to the point, but also set the zoom level to 14. So if I change that, it's going to zoom in. I could also do something more complex where I'm saying, okay, also go to that target and zoom and do an animation as well for 2 seconds. So now it'll zoom a little bit slower. Or if I really want to customize this, I can go to a location and set a custom easing function. So this animation is going to look even different because I've defined a different function for easing. So this one starts out a little slow and then gets faster. So there's all kinds of custom things you can do with view.goto, and it's a nice, easy way to jump to a location. Another cool thing I want to talk about in the API is collections. These are like arrays, but they give you a lot more functionality. And kind of the key piece of that is being able to listen to when the collection changes. But there's a whole bunch of other things you get from the collection. It's like a modern array where you get things like find and filter, find index. You can easily loop through it for each.
We have a flatten that works.
We have a flatten function or method that will convert it from an array to, or from a collection to an array. You need to use that. So we use this a lot in widgets and throughout for things like storing layers and a collection of layers. So let's look at a little demo right here. Let me open the code for that. So in this demo, I'm just creating a collection. It's going to be empty by default, but I can push a few different things to there. So I can push one item, or I can add a bunch at a time. And then if I reload this, I'll see my collection has those items there. If I want to listen to different changes, I can do that. So when the collection gets changed, it's going to throw an event. So if I do my collection.pop to remove the last one, then I get a little event of what was added, moved, and removed. So it's kind of nice. I can do something like find a specific item in that collection. And yeah, it's pretty cool. We use this a lot throughout our API. So another cool thing about our API that's redesigned is most every class is using Accessor. It's kind of like the core of our API. And this means that everything is more consistent and we have less events. So instead of a ton of different events we had in 3x, we have properties that you can watch in 4x. So instead of knowing like, okay, you have to listen for this long event title, you can just watch the property and it's pretty self-apparent. So accessors let you read and set properties of a class. So instead of a bunch of different methods like set attribute, get attribute, you just look at the attribute property. And they're watchable with watch utils, which is a nice utility we use in the API a lot. So here's an example of how you'd get and set properties on an accessor. So to get one, you just do layered opacity, or to get one, you just do, or set one, you just do layered opacity equals 0.5, or you can set a title, or you could set multiple different things at once, right there. And a nice handy thing about getting properties is you can get descendants as well. So if I want to get the title of the base map of the map, I can use, of the view, I can use view.get map.basemap.title. And I can also set things that way too. Here's an example using watching properties. So if I want to watch the scale of the map view, I can just do mapView.watch scale, and I'll get an update anytime the new value changes. I'll get the old value, the property name, and target. So I can do this for just one property on the thing or descendant of the properties right here. So if I want to watch the title of the base map of the map, I can do that too. I can watch when the map view is ready or stationary, so I can watch a couple different things at once. Or I can use something like watch utils and say whenever the view is true, or whenever the view is stationary, the view is stationary. So pretty cool watch utils. It's in our doc right here under Esri core watch utils, and you'll probably see it throughout the API being used. Renee mentioned a little earlier about autocasting. And what this does is it lets, our API uses a lot to automatically instantiate classes without having to import all the classes and then instantiate them yourselves. So if you wanted to create a simple marker symbol, you could easily do that without having to import all the different things that you need to create that class. So here's a demo with collection. Let me show the code. So we have a collection right here. We're just creating a new collection. And then we're going to add a point to it, which is right now just an object with latitude and longitude. So if I look at that, and I go into the console, my collection, it has items, and it's just got one, and it's just an object of latitude, longitude right there. But if I want to autocast something, I can say that this collection is going to be a type of point. So my point collection is a type of point, new point collection. And then if I add this object, it's going to autocast that into a point. So if I reload this, now you see there's a spatial reference there. I go to my collection, I'll go to the items, and I see that it's now an accessor class, which is a point. So it's a cool little handy thing to be able to automatically instantiate a class from something like a simple object. Promises. So I'm going to turn it back over to Renee, and he's going to talk about promises.
All right, oh, cool. I know we don't have much time left, but I'll be pretty quick on this, but we started introducing native promises in the latest release of the API. Basically, that means that lots of places you can just start doing this like a query on layer features, and it'll return a real promise to you. You can then use the .then method to handle a result, or use .catch to handle errors. So it just works like a regular promise. One of the big benefits of this, though, is the fact that you can now start using async await, which is another way to deal with asynchronous operations. So if you want to use async await, you have to have a function that uses the async keyword to define it, and then you can just start stepping through your code, kind of without having to wait for anything to come back. In this case here, my results are going to be equal to the await of my query. And once the results come back, I'm done.
You got to turn back to your...
Am I not on me?
No.
Am I not? 3? There we go. Okay, sorry. Here we go. This is the .then result. And here's the async await stuff that I was talking about. So I have my async function. I'm going to await the results of a query. When those results are done, then I can do something with them. One disadvantage to this, though, you might be able to see just by looking at this, is that this is going to block my code. Everything under the await function needs to wait for the result to come back before it'll execute. One of the benefits if you do just .thenables is you can have a .then block and then code under that block, like after that executes, that can still execute while you're waiting for the results to come back. So it's kind of a drawback. You just have to learn how to structure your app if you're going to take advantage of async await. Also, notice there's no way to catch errors here. The way you catch errors with async await is wrap the await call with the try catch. So it's kind of, I think it's a little annoying. I do use async await, but yeah, it takes some getting used to. Is all I have to say. But it's cool. It's a nice way to write your code. It looks a little cleaner. If you don't mind having try catch calls all over the place. To do this, certain classes in the API are promises. So like a map view is a promise class, but it's a promise class out of the API, so it's not compatible with native promises. So to solve this problem, what we did is that we added a .when method on those classes, and they do return promises. There's a list in the SDK that lists out what those classes that extend our promise class are. It's like view, and I think layer might as well. But yeah, just look at that list and you'll figure out where to use .when at. Right now, okay, so here's how you do this, a view.when. Then I get my layer view that returns a real promise. Now I can start using .then at this point, and I can chain my promises and do some pretty cool stuff. Loadables, let's talk about loadables. Loadables are a cool way to work with your data. We pretty much stole this right from runtime. So for example, I have a WebMap or web scene, and I want to access the data as part of the WebMap web scene, but I don't care about displaying it. Maybe I got charts or I have a report. I'm going to pull information out to fill out. So when I do that, I can just load my WebMap. I can find a layer in my WebMap, load that layer, and then I can start querying the layer. When you first create a web map, we don't bring in all the data. We don't get all the layers. We don't load layers. Nothing. It's just the bare minimum we need to know information about the web map. Once you load the web map, we have all the details of the web map, but we don't load the layers because we're just waiting for something to happen. This is kind of all handled with the views behind the scenes. This is a great way to start lazy loading data in your app. So you can initialize 50 or so web maps if you want, not load them, but just kind of interact with them as needed during the lifetime of your application, which is a really cool feature. So at this point, we'll go ahead and take any questions. Please fill out the survey. Don't make any comments about the power going out. We appreciate it. Thank you. Any questions? Yeah. Yeah, we have that's there from, we just took it from the 3D stuff that was there. We do a check, yeah. Any other questions at this moment? Everybody's tired. Oh, yeah.
I wasn't able to
Oh, you want to try and mix 3x and 4x together? We don't have a sample for that right now. You could, you're going to lose, what happens in that case is you pretty much create a, update your Dojo config. You're going to point like Esri 4 if you're using 3. Create an Esri 4 package and point it to the CDN version of the 4script 4x API for the Esri folder and refer to it as Esri 4 throughout your app. You lose the built file capabilities we have though. So like a lot of stuff is built into the Dojo.js, and map view is actually a layer file, so you're cool there. So is, I believe, WebMap. I don't think map is though. So you're gonna load more files that way than you normally would. But I did help someone do something for a web app builder widget one time that loaded a scene in the widget that they used in a 3x version of web app builder. So you can do it. It's not pretty, but you can. Anything else? All right, thanks, folks. Appreciate it. Have a great time. Thank you for coming to the Dev Summit.